Hello guys, welcome once more to class online. My name is Tutodami and we shall be clarifying a lot of things in this edition. In this edition, we shall be learning about aspects of physics that has to do with why is it that steam from a boiling pot will burn the skin more than the water itself. What I mean is that why is it that steam, that smoke coming from boiling point, burn more than boiling water itself? So that means we will explain that also, and among that we will explain other part of physics that will help to clarify a lot of things. Now let's see. Don't forget that if you learn something from this video, click on like button. We have more content to send to you that will better help you understand physics. Let's see number 21 now. Steam from boiling water causes more damage to the skin than that of boiling water. Because why? Why does steam hurt the skin? Now some people will say, but that's not true. But that's true. That's actually true. Okay, that's actually very true. And there's a reason. Why is it so? A, water has a high specific heat capacity. B, steam has latent heat of fusion. C, the steam is at higher temperature than the water. D, steam brings heat more easily by convection. Now, actually, there's only one answer in that question, and that is this. Now, look at my pot. You can see the picture of the pot there. The pot is boiling, right? Now, what happens when water boils? We can explain it that the heat is below. The heat is below. That means the heat is coming from the pot, from the stove or from the gas into the pot, right? Now, what happens to the water? The lower part of the water will get very hot, and all things are lighter. So when the lower part of the water gets very hot, it will go up, while the cool one on top will go down. Because hot water is lighter than cold water. So cold water will go down, so the water will keep rolling. The hotter one will go up, while the colder water will come down. So the water will keep rolling, and that's why you have bubble system in water. The hotter water is lighter, so it will be going up, and the colder ones on top will be going down. And when that keeps happening, that's not why we have why steam burns more. The main reason is because as this continues to happen, the water gain more energy, and that energy is called kinetic energy. So the water gets hotter and hotter and hotter until the water change form. So it will change from liquid into vapor. That's gas. And at that point, gases have more kinetic energy than liquid, and gases move faster than liquid. So, and gases are, if they have more kinetic energy, it means that gases are hotter than liquid, and that's why steam is hotter than the water. Because for you to have kinetic energy, you must be hotter. So temperature increases what kinetic energy. That means the hotter that thing is, the more the kinetic energy it will have. So that means water is water because it is not hot enough, and that's why water is slower than steam, than gas. Gases are faster than water because they have more kinetic energy than liquid. Okay, and gases move faster, and that means that gases are hotter than liquid because they have more kinetic energy than liquid, and that's why the steam coming from the pot will burn your skin more than the water. Why? Because it has more kinetic energy, and it is hotter. So because it has more kinetic energy means that it is hotter than the water itself. So the steam coming from the water will burn more than the water because it is hotter than the water, and the proof is that it has more kinetic energy, so it can move freely than the water itself. And that is the answer. So the answer is C. The steam is at a higher temperature than the water, and that is why the steam will burn the skin more than the boiling water itself. And that is the answer for number 21. Let's check out number 22 now. What will happen to the boiling point of a pure water when it is heated in a place 30 meters below sea level? Now, many students understand a lot about this. That if you take water and you boil water on the mountain, okay, that water will boil. Now, you know that it is at higher pressure, right? On the mountain, there's higher pressure, and pressure increases what? Boiling point. Pressure causes, and that's what I have here. Pressure causes boiling point to increase, but it also makes what? Melting point or freezing point to what? Decrease. So also impurity. So pressure and impurities increase boiling point and decrease melting point or freezing point. At the mountain top, we have higher pressure, so it will cause the boiling point to increase. Now, but this question is not talking about mountain top. This question is talking about under the sea, lower point. Now, you will say, now many students were saying that the answer will be less than what? 100. Under the sea, there's also high pressure. On the mountain, there's high pressure. Under the sea also, there's high pressure. And that's it. But at the sea level, there is normal pressure. So there is increasing pressure at the mountain top as much as under the sea. Okay? And that is just it, because the pressure under the sea is caused by water molecules moving. And the pressure on the mountain top is caused by air molecules moving. So both of them are under pressure of molecules. And that is it. So now there's high pressure under the sea. That's at 30 meters below the sea level. So it will there's high pressure, it will increase the boiling point. So the boiling point, it will boil at, it will be more than 100 degrees Celsius, because there is high pressure at 30 meters below the sea also. And therefore the boiling point will also increase, and that is the answer to that question. It will increase the boiling point also. Just like on the mountain, so also it will be 30 meters below the sea level. And that is it, because both points have high pressure, and that is making the boiling point to be higher or more than 100 degrees Celsius. So if I take water to the top of the mountain, the water will boil more at a temperature more than, so that means the boiling point of the water, that means the water will not boil easily because there's high pressure. Okay, then if I take it below the sea, under the sea also, it will not boil easily because there's also high pressure. Okay, so that's the answer to the question. It will be more than 100 degrees Celsius. Now, number 23, the rise or fall of a liquid in a narrow tube is because of what? The rise or fall of a liquid in a narrow tube is called capillarity. Now, capillarity is caused by what? Why do, now if you take Fanta or Coke and you put a straw in it and you suck it, the Coke will come to your mouth, right? How does it come to your mouth? That process of rising through that tube is called capillarity in science, and that is the rise or fall. So if you stop sucking, it will fall, but if you suck, it will rise. You are pulling the liquid through now, and you can pull it because it is water. Okay, it is it is like water. Okay, now, and that is it. But what causes it? Is it because of the viscosity of the liquid, or surface tension of the liquid, or friction between the wall of the tube and liquid, or osmotic pressure of the liquid? Do you have any idea which option might be correct? Now, the answer is very simple. Like I have it here. Now, you can see that water has a concave meniscus, right? That means water able to suck. The reason why water can rise is because it has great attraction for glass. You know that water wets glass, but mercury does not, right? So you can suck water easily because water wets glass, and that is caused by the force of adhesion between water molecules and the gas molecule, which is a function of surface tension. Okay, so the surface tension on the water is lower because the water can wet glass. So if you suck that water, it will rise. So the reason why it rises is because it has more affinity or love for glass. So it is easy for water to rise in a tube because water has more adhesion force than cohesion force. So that means water can splash on things, but mercury has more cohesion force. It does not splash, it forms ball. So you can't suck mercury, but you can suck water. And that is it. And that's the reason why water rises in a tube like that. So it is because of the surface tension on the water the water can rise easily because it has a weaker surface tension than mercury, so it can rise easily through that fluid. It is due to the surface tension of the liquid. Now, number 24 says the mechanism of heat transfer from one point to another through the vibration of molecules of the medium is what? Now, this is heat transfer. We know that for anything, this is heat transfer. We know that for anything heat transfer, it has to do with three mechanisms: conduction, convection, and radiation, right? Heat transfer in solid medium is called conduction. Heat transfer in liquid is called convection. Heat transfer in gases, in liquid and gas is convection. But heat transfer without a medium is radiation. But diffusion is not even among the heat transfer methods. So diffusion is just the wrong and the useless option among the list. Now, but heat transfer by the vibration or the movement of the molecule, not really movement. They are not really moving. They are just vibrating or shaking. Heat transfer by the vibration of molecule is what? Is it convection, conduction, or radiation? Now, some people will say because they say molecule is convection, but that's wrong. The answer to that question is very simple. It is conduction. And the reason is because the question said by the vibration, not by the movement. Conduction is by the movement of molecule. But convection is by the movement of molecule. But conduction is not by movement, it is by the vibration of molecules. So now what I mean is that if you put a metal in fire, the heat will flow from the metal to your hand and burn your hand. That process is called conduction. That means the heat could get to your hand by conduction. Okay, and that's what I have here. The heat will move from the candle to the hand of this guy. His name is Bola. So the heat will move from the candle to his hand by conduction. And now the big question is, how did the heat get to his hand? A molecule in a solid body is vibrating. That means the molecules in the solid metal, they are vibrating. That means the ones at the fire, they are very hot, and they will now be vibrating and be transferring the heat to the ones closer to the hand of Bola until the heat gets to the hand of Bola and burn his hand. And that process of heat transfer by the vibration, not by the movement, but by the vibration of molecules, is conduction. But the heat transfer by the movement of molecules, like I have it here, is convection. And that's what you have in boiling water. The water molecules are moving from up to down, up to down, up to down, up to down, and they are circulating until the whole water is boiling. And that is convection. But the heat transfer without a medium or without any material medium, okay, through empty space, is called radiation. Like the sun ray coming to burn this girl, this fine girl. The sun ray is coming, shining on her and making her feel hot. Okay, and that heat transfer without any medium is called radiation, and that is the answer. So the answer to that question is just conduction. Heat transfer by the vibration, not movement of molecule, is conduction, and that is the answer. Number 25. A wave that travels through stretch spring is known as what? Now, if I have a spring and I stretch it, that wave that travels through that spring is called what? Is it electromagnetic wave, or microwave, or mechanical wave, or seismic wave? Now look at this now. Electromagnetic wave are waves that travel without a medium. Now if they've ever mentioned spring, that means it is not electromagnetic wave, because electromagnetic wave does not travel through anything. It travels through nothing. So electromagnetic wave is wrong. It's not the answer. Electromagnetic wave are waves like light. It travels through nothing. Okay, so now mechanical wave are waves that travels through a medium. And in this question, the spring is the medium, making mechanical wave the answer to the question. Mechanical wave travels through medium. They are waves that travels through medium, like sound wave, okay, like water wave. They are both mechanical. That means they travel through a material medium, and in this case, it is the spring, and that is the answer. Like if I have a guitar, the sound of the guitar, if I strike it, it will travel through that spring, right? And it will produce a sound. So sound wave travel through spring, and then that means that it is a mechanical wave, because mechanical wave are waves that travel through materials. And the answer for number 25 is just mechanical wave, and you can see the examples there on my chart there. That brings me to the end of this session. Don't forget that if you learn something from this series and you want to get more content from us that will better help you understand physics, click on like button. We have more videos to send to you that will better clarify things. Until we see you again, guys, take care of yourself and bye for now.